Hello guys, welcome back to Carry Code. In this video, we are going to discuss about stock price prediction. So basically, we are going to learn about how to predict the stock price using machine learning. Without any further delay, let's get into the work. First, I'm creating a Jupyter file. I'm renaming the file. Our first step is to install the required packages. Like, we have to install Finance package. Let's install it. Pip install Finance. I'm installing this package to download all the stocks data about any company. Let it install. So here it is showing that requirement already satisfied because I have already installed it. But if you are not installed it, you have to install it using this command. Let me comment out this. After we have to import it. Import Finance as YF. So we use this package to download all the stock data. Let's run it. And to import this data, we also have to think about how much data, like how many years data we want to download. So let's define the start and end dates to get the stock data in between. Let me create a variable start. Before that, I have to import date and time, right? So from date time, import date time. Then I will be defining two variables. The first one is end and the second one is start. So end date is the current date, right? We have to extract data from certain date from the past to until now. So the date time is, so the today's date time is date time dot now. This is how we define today's date time. Then if I want to get the past 10 or 20 years data, I can do this. Take date time n dot year minus, if I want 10 years back data, I can give minus 10, and then n dot month comma n dot day. So I will be getting the past 10 years data if I give minus 10. So if you want to extract last 10 years data, we're gonna give minus 10 or minus 20 to get last 20 years data. Let's run it. So we have defined the duration of our data to download from that website. So let's go to Yahoo Finance website, from where we're going to download all this stock data. Yahoo Finance. Go to the first link. See this website, we have all the stock data. If you want Google stock data, you can search for Google like this, Google. Then you will be getting Google stock data here, and this is unique ID that is assigned to Google in this website. So to download this Google data, we won't do it through the UI, but instead we use this Finance package here. So in order to extract this data, we need a ID of this company. That is nothing but, I have mentioned it before, right? This Google. This is the unique ID. Let's copy it and initialize the variable stock here. Stock equal to Google. And to download this stock data, we can just give yf dot download of the stock data I want to download. That is, I have already defined it, Google, and the start date from where you want to start the extraction until which point, that is today. And let's store this data into a variable called Google data. Google data. Let's run this cell. It will extract the data from that website for past 20 years. Right, we have given minus 20, so it extracts past 20 years Google stock data here. So it's completed now. Let's see how our data looks. Google data dot head. It will show us the first 5 rows of that data. These are the first 5 rows of our Google data. If you see the first row, it is from 2004, as we took data from past 20 years, and it has 6 columns here, like open, high, low, close, volume, adjusted close. Like that we have 6 columns here. Coming to open, it is the open price of the stock for that certain date. And same as open, we have high, low, closing price of the stock and volume of the stocks. And there is adjusted close price here. The difference between the close price and adjusted close price is they both are almost same, but the adjusted close price considers other factors like dividends, stock splits, and new stock offerings. I can say that adjusted close price is more accurate than the close price here. Let's analyze this data set now. First, let's see the shape of this data set. Google data Google data dot shape. So we have 4908 rows and 6 columns here. And now let's use describe and analyze the data. Google data dot describe. We can see it listed out all the metrics like number of rows, that is count and mean, standard deviation, the minimum value and the maximum value, like that. We can also use info function to see all these type of data. Google data dot info, like that. Let's run it. We can observe here the mostly all the data is in numeric format like float and int. We don't have any object or string data here, so we can skip the step where we can convert the object data into the numeric format. Now let's check for any null values or empty cells. To find the non-available or null values, we can give this command like Google data dot isNA. By this command isNA, we will get to know that value in the dataset as null or not, like true or false. And then we are just giving this dot sum function to add all those true values which are null. In this case, let's see how it looks. So in this case, we don't have any null values in this dataset, so it is 0 for all columns. It is good. It is clean dataset, I hope. Now let's draw some graphs to understand the data much better. To do that, so we have to import matplotlib library. Let's import it. Import matplotlib.pyplot. Yes, plt. We have to give like this matplotlib inline. So this is how we import this matplotlib. Let's run it. Let's plot the graph for adjusted close price and yes. You can see in this dataset there is one column that is a close prices, right? We can use this column either or the adjusted close price. So I would like to use the adjusted close price column as it is more accurate indicator of stock values. Before plotting the graph, let's define its size as 15,5, like plot.figure fixed size of 15,5, and just plot this adjusted close column using plot like Google data. Take that variable adjusted close price and then dot plot. So let's also give the title to the graph and labels to x and y axis. Plot plt dot x label of years and plt dot y label of adjusted close price, right? And then let's give the title of this graph as closing price of Google data. Let's run it. Yeah, hit u equal to here. So this is the closing price of Google data graph we have drawn. You can see the graph data is increasing like this and down somewhere 2023 and up again 2024 here. If we want to draw a similar graph for all other columns, we can do the same or create simple function to do it for us. Let's create the function def plot graph. Inside this plot graph, I just copy paste all this content, right? Copy it and then paste. If you see what are all inputs we can change here is the figure size, right? I'm taking it as input here again. So instead of this 15,5, I can give that figure size. And the values to plot, that is the Google data values right here. I'm gonna change it to values and take as input here values, comma, also the column name, right? Column name to give it here in the y label. Also here in the title. So I took 3 values as inputs here. First one is fixed size and second one is values and finally column name. I have replaced all of them here. Here the x label remains constant, that is years. Let me shift this figure size to the plot so it is very accurate and it will recognize it. So let's run it. Let's see the columns of the dataset we have extracted. Google dataset dot columns. You can see there are 6 columns, right? I just want to print the graph to all those columns. I can simply use a for loop and call this function, right? Let me do this. Now I will call this for loop and iterate over all the columns and call the function plot graph. For column in Google data dot columns plot graph of, let me define the size 15,5, comma Google data of the column name and the column name again. So let's run it. It will draw 6 graphs beginning with starting with open and until volume. So open of Google data, so it is the open data, and this is the high values data and low values data, and this is the closing price data, this is the adjusted close price data, and at last this is the volume, right? Pretty much simple to draw all these graphs. So until now we have discussed about drawing some graphs for those columns, right? But how do we actually predict the stock data? Let's discuss about this with an example. Consider a stock like Google. If you see, there are many attributes in the dataset like open, high, volume, close price. So let's not get everything here. So let's work around a single attribute like closing price. For example, I will take 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. For instance, just imagine this as closing price of any stock data, right? This is the first 10 days closing price data. Like 10 is the first day and 20 is the second day, and so on. There is a concept called moving average, where we calculate the average for specific range of dates in the past counting from today. If I want to calculate moving average for 5 days for this whole data set, then we have to calculate it for 5 days, including the current date, like 10 to 50 and 20 to 60, like that we have to calculate for 5 days. And the calculated moving average is stored parallel to the current date, that is to the 50 if I calculate from 50 to the back previous 5 days, right? So if I want to calculate the moving average for 5 days, for the first day, that is the value is 10, but the moving average will be null because I don't have the previous 4 days data to calculate the moving average for the first date, that is 10. And it is same for second date, third date, fourth date. So until here it is same because we don't have previous 4 days data. And coming to the 50, so let me write this null, null, null until 40. Coming to the 50, I have previous 5 days data including current date, that is 10, 20, 30, 40, 50, because I want to calculate moving average for 5 days, right? So I need the previous 4 days including current date to calculate the moving average. So if I want to calculate the moving average for this data, it is very simple. The formula for calculating the moving average is, let me take the same data, temporary data, then comma 10 to 100, and I want to calculate it for 5 days, right? Print, I'm going to take first 5 values, right? Temp data, let's take 5, and I have to add it because it is average, right? Sum of 5 values divided by 5. So let's run it. It is 30, right? Now the moving average for 50 here is 30, and then we can also calculate it for 60. For 60 it is, let's do this, from first index to sixth index and divided by 5, right? It is 40. If you see, it will be increasing 10 times as I'm taking the linear data, right? So it is. Now if you see, the moving average for 5th day is simply the average of previous 4 days including the 5th day. So here 30 is moving average for 5th day, and for 6th day it is 40, and 7th day it is 50, and so on like that. So I hope you understand the moving average concept here. The same moving average concept can be calculated using data frames, right? Let me show it to you quickly. Data equal to pd dot data frame. Before that we have to import the pandas. Import pandas as pd and data frame of the same list, right? Let's see the data here. I have to give capital D. So let's see the data frame here, 10, 20, 30, 40, 50. This is the first 5 rows of this data set, right? if I want to calculate the rolling, if I want to calculate the moving average for this data set, I can use a formula here in the data frame, like data dot rolling of, I need the moving average for 5 days, right? So 5. So for every data value, I need a moving average for 5 days. Dot mean. So this will give me the moving average for that 10 values. Let's see. So if you see, the first 4 values is null here. As I said, the first 4 values is null, and then 30, 40, 50, 60, 78. See, 30, 40, 50, 60, 78. It is same, right? So if you see, for data 50, we got a moving average as 30, and for 60, it is 40. Data of moving average data. So if you see, for 50 it is 30, and for 60 it is 40. Now I hope you understand this moving average concept. So you can ask me, why do we have to know this concept to predict the close price data? Right. Using this moving average concept only, we will be predicting the stock data. The same concept comes here in the prediction also. I will be taking first 10 days or 20 days or 100 days data and use this data for training to predict the next day close price. So I will feed this training data to a neural network as input training data and then predict the next day stock data. You're understanding, right? If you understand this concept, you can able to understand what I'm saying. So let's analyze the few other graphs using this moving average concept. You have already seen that I took the stock data for past 20 years, right? Let's count how many days are recorded for each year, guys. So I'm taking a for loop for I in range of, I took it from 2004 to 2024, and let me print the Google data dot index to get the dates, and I will get the specific year, and let me count. So to do that, I have to convert this into a list first. List dot count of I. So I'm taking all the years from the index of this data and counting the number of days in each year, right? Let me print I also here. So if you see, in 2004 94 days is recorded, and in 2005 252 rows, and so on until 2023 250. If I give 2025, it will be 2024, right? Let me wait. In 2024 it is just started, right? So it is 33. So on an average, we got 250 number of days per year, because the stock data trading or exchange will happen only on weekdays, right? If we remove all the Saturdays, Sundays and public holidays, we'll be left with those 250 days data. So let's take a moving average for 250 days and see how the graph looks. Google data. Let me store it in moving average for 250 days variable, and then Google data. Remember the variable name, that is adjusted close price, as it is more accurate than the close price. So I'm taking this variable dot, you remember the moving average formula here, dot rolling of 250 days. Previously I have took 5 days, right? Like that I'm taking 250 days here, not dot mean. Let's run it. Let's see this moving average data, but remember, we will not see any data for the first 249 rows because its previous dates data is not available, right? If you see here, for 5 days, previous 4 days values is null. Like that, if I took 250 days, the 249 rows, it will not have any data for moving average. They are null. Let me show you. Google data off. Let me copy paste the variable name here. Let me take, if you see here, see this printing all the rows 4008. But if you see, the first starting it is null, and then at ending you have some values. But if you consider looking at 250th row, you'll be able to analyze from where the actual value starts, right? So I'm giving it as I'm starting from 0 and ending at 250th row dot tail. So I will get a last 5 rows starting from 250. So if you see, this is the 250th row and this is the 249 row. So from 0 to 249 there is no data for moving average. If you see, data is available from 250th row. Let's draw the graph for this moving average for 250 days versus year. We have already defined a function to plot the graph, right? That is plot graph. So let's use it. Plot graph. Sorry for that. Graph. I have to give the figure size 15,5, and the values, that is Google data, of the same variable I'm taking, and the variable name, it is also same. Let's run it. Okay, I have to close it with this parenthesis. Let me run it. So if you see, the curve is somewhat smoothened, right? This is the moving average for 250 days of the Google data. I have calculated for the whole data, right? Let me send the adjusted close price data also to that graph. So I'm able to see both values in single graph. Adjusted close price, comma, and I have to give then bracket here. Let's run it. So if you observe here at the beginning of the graph, the orange curve is, that is a moving average curve, is started after a few days, because moving average is null for the first 249 rows. We can do this for any number of days and analyze the curves here, how it changes. Let's see for random number like 100 days. I can do the same rolling.mean here. Let's copy this, paste it over here, and instead of 250 I'll give 100, and then copy this plot graph function. Let's call it here also with 100 days moving average data. Let me run it. So if you see, now you can observe this is moving average for 100 days of Google data, but I want to draw this 250 days and 100 days moving average data along with this all adjacent close price, adjusted close price data in single graph. We can also do that. Just copy this and paste it over here, and you can send 250 days data also here. Just paste this variable here like that, and you can give the name as moving average. Let me run it. So if you observe here, the 100 days curve line, that is the orange curve, is more similar to the original curve, that is the blue curve, and less smoothened than 250 days curve. But if you see this orange curve is very similar to the original data. Then this green curve, that is 250 days data. So we can take 100 days of previous data and predict our next day price more accurately using this neural network. So through this analysis we can find out that how many days can we use, right? Before going to create our model, let me tell you about another small function which may be useful in our analysis, that is percentage change. It is very simple, that it will tell us how much percentage the close price value is changed from the previous day. Let me write and show you in the command. Google data, let me store it in percentage change close price equal to Google data. Let me take adjusted close price dot pct change, that is nothing but percentage change, right? Let me print it. Let's run it. So these are the percentage values, like how the close price is changing for each row. If you want to see it more clearer, I can do this. Just add close price, comma, I'll close this dot head to print first 5 rows. Oops, let me remove it. So if you see here, the first value is none because we don't have the previous data for this row to calculate the percentage change. But if you observe the second row, that is 2.6, it is changed from 2.4 to 2.6. That is some increment, right? Somewhat percentage increment. That is nothing but this 0.079430 percentage, it has increased. And if you see the third value, it is 2.7. It is increased from 2.6 to 2.7. It is same, 0.01 percentage, it is increased. And if you see the fourth value, it is decreased from 2.7 to 2.6. That is, to indicate the decrease, it is assigning the negative value, and 0.04% it is decreased. So we can even draw this graph to analyze the percentage change in the closing price data. Like, copy it again, paste it over here, and instead of this whole column names, I can just give this percentage change column name. Percentage change. So this is the percentage change of the Google data all over the years for the past 20 years, I say. So the data analysis part is completed now. Let's pre-process our data to make it very easy for our model to get trained. Now I will take the close price data. Let me store it in adjusted close price variable. Google data. I'm taking the variable name adjusted close price. Let's run it. Now I will pre-process our close price data. I want to normalize our input data, that is the close price data. Normalizing in the sense like I will convert all this data into the some range of 0 to 1. Now if you observe, I will take the max and minimum values for this data now. Max of dot values, come on. Max and minimum values, I'm printing them. It is the maximum value is 154 and the minimum value is 2, right? So now I will convert this data into a range of 0. So now I will convert this data in the range of 0 to 1. Instead of 2 to 154 range, I will convert this data into 0 to 1. So because if I convert them into 0 to 1 range, our model will get trained faster because these are the smaller numbers, right? So let me do this. To do that, I have to import the min-max scalar from sklearn. From sklearn dot preprocessing import min-max scalar. Let me create an object for it. Scalar equal to min-max scalar of feature range. Okay, can you anybody guess it? It is 0, 1, right? We have to convert it from 0 to 1 range. And scalar data equal to, what is the scalar data? I want to transform the adjusted close price to 0 to 1 range, right? So I have to do it using one simple function, that is scalar dot fit transform of this adjusted close price. Let me print this data, scalar data. So if you see, it is 5 and power minus 0.5, that is 5 power minus 5. So if you take it in here, it will be like 0.000 zeros and 5, right? So it is very less. So it is in the range of 0 to 1. They all will be in the range of 0 to 1. Let's see the length of our selected scale data. Length of scale data. It is same as our previous data, right? 4908. It's time to make our x and y data here. So take x data and y data list here. Let's take x data as a list, and same as x data, I can take y data as a list. From the scale data, we will be extracting our x and y data. If you remember, I said we will be using the moving average concept here. I will be taking 100 dates of previous data as input training data for each of the price in the dataset. In the sense, I will be taking 1 to 100 rows of data as training data. In the sense, I will be taking 1 to 100 rows of data as input training data to predict 101 row. You're understanding, right? And for 102 row, I will be taking the data from 2 to 101, and so on until 4908 rows, right? Let me remove it. So let's see how we can do this. I'm taking a for loop for I in range of, you consider I'm taking the 100 days space, right? The previous 100 days. So I'm starting it from 100 because the previous 100 days, that is the 99 days, will be having null values if I take the moving average, or if I want to consider the predicting values, I should take the previous values. But for 99th row, we don't have 100 previous values. So I'm starting from 100th row. So I'm starting from 100 row. 100 comma length of scalar data. For x data, I will be appending the scalar data with 100 values, right? I minus 100. This will be the first 100 set until 100, right? So for y data, what can we append? Can anybody guess? Yes, it is scale data we can just append only one value, that is I, because we are predicting it, right? So we will be predicting the y data using the x data. So if you want to predict this I value, we have to take I minus 100 values, that is 100 values data, the previous 100 values data, to predict this ith value. Let me convert this x and y data to a numpy arrays so I can make operations easier. To do that, I have to import numpy. Import numpy as nb, and we can do it in one step. X data comma y data equal to np.array of x data comma np.array of y data. Let me run it. You can also see this data, x data 0 comma y data 0. So if you see, our x data is having so much data here. It is like 100 values, as I said, and the y value is only one value. Using this previous 100 rows, I will be predicting this one value, right? You're understanding what I'm saying, right? Let's split our data into training and testing dataset. In this case, let's take length of x data, and I will take 70% of the data as training data and remaining 30% as testing data. Let me take the length of our data, length of x data. So I'll be taking the 70% data, right? So into 0.7, and I have to convert it into integer. Let me print it. So my 70% data is 3365, and if I take the testing data, 4908 minus this value, right, that is 1543. But if you observe, we have removed the first 100 values of our data set because they are null values. If I want to predict them, I need a previous 100 days value. So I'll be taking minus 100 here because I did remove those 100 rows. So our testing data is 1443. So it is clear, right? Let's do this. So splitting length. So splitting length equal to, copy this length, paste it here. This is the splitting length. I'm taking the x train equal to x data until splitting length, right? Copy it, paste it. I'm taking the y train data from y data with same length. Now I'll be taking x test data. This is the 30% data, right? So I'll be taking splitting length until the end. Let's copy it. I'll be taking same for y test also. I'll be taking same for y test also. Let's run it. So let me print the shapes for these data sets, the training set and the testing set. Print of x train dot shape. Let me copy it, paste it 4 times to print a y train shape and x test shape and y test. If you observe, the 70% data, 3365 data, is in training data set of x train and y train, and the testing data 1443 rows are in x test and y test. This is as simple as that, to split the data into training and testing data sets. All good? So let's start building our neural network model to predict the closing price. Here I am using quires, so I can add different layers to our neural network model. So to import that, do this from quires dot models import sequential. Here I am also importing dense and LSTM from this quires. From quires dot layers, we can import dense comma LSTM. So I imported this dense and LSTM as I will be using this LSTM, that is long short-term memory layer, and few dense layers to build our model, right? Let's run it. To build a model, I have to take an object. So to do that, I can give model equal to sequential. Here I am importing the sequential model, so it transfers the data from input layers to the series of layers and then to the output layer. Here our first layer is LSTM. So model dot add of LSTM. Let me take the number of neurons as 128 first, and I will be taking the return sequence values as true. Return sequences equal to true, and at last I have to give the input shape. So this is our first layer. I have to give the input shape. So I'm giving it, had given it. The reason behind I have given this return sequences as true is that it says the input to the next layer is a single vector or the sequence of vectors like that. Here in this case it is true, like, so it is a sequence of vectors. And our first layer I have given the input shape here, and I transferred our training data here. So our first layer I have given the input shape here using this training shape, using this training data. Let me add the second layer, that is also LSTM. Model dot add LSTM with 64 neurons, and same as first layer I am giving the sequences, but in this case it is false because I am not giving it as a sequence. And model dot add of dense layer here with 25 neurons. Good. And then our last layer as model dot dense layer again with only single neuron. This is our output neuron and this is our output layer. Let's run it. So it is running. Let us compile this model. So to do that I can give model dot compile, and I have to transfer two values here. That is, the first one is optimizer. So if I want to say the optimizer, what is optimizer, it will take a long video, so just put it aside. It is just to optimize the running of this model. It is Adam, it is just an algorithm. On loss value as this is a matrix, that is mean square error. So let's run it. That is, let's compile it. It's completed, and then let's use the training data to fit into our model. To fit it, we can do model dot fit of our training data, that is x train comma y train comma. We can also give some other parameters like the batch size. So it will segregate our input data, that is training data, into some batches. And here the default value I'm giving it as 1, but we can take as many batches I want or you want. And the number of epochs, I'm taking it as 2. You can give any number of epochs, but it will take long time if you give more epochs. The epoch is nothing but it will run our dataset. It will train our dataset into this number of epochs. Like the first, it will take this many batches, and then it will train over those batches once, and it will take another batch and it will train again. So like that it will train this many epochs. Let me run it. It will train for 2 epochs. I think it will take some time. Until then, I'll tell you what we have discussed until now. So coming from the first point, we have imported our data from the Y Finance website using the start and end duration, and we have seen the shape and described the dataset. We have seen what are the metrics we got, like count, mean, standard deviation, minimum and maximum values. We can analyze all of them. And the info to get all the data types of the variables. Here it is a float and int mostly. So we don't have object data on the string data, so there will be no need to converting the object into the numeric format. I have skipped that step because we don't have any objects or string values. And I have checked it for any null values, but we don't find any, luckily. And I have imported this matplotlib to draw some of the graphs between all the columns and the years. And I have defined a function to iterate over all the columns to create those graphs, right? And then we discussed about this moving average concept. I hope you understand all this concept. If you don't understand it, please watch the video again, and feel free to comment again. If you don't understand, I will do another video recording it. And we have seen the moving average for 250 days here, and we plotted a graph here and seen it. Then we have plotted a graph seeing that adjusted close price and then moving average for 250 days. The curve is smoothened, but it is not very similar to the original price. So we took a random number like 100. So it is somewhat more close to the original price. So we took 100 days as an space between the predicting values. So I will be taking the 100 days, that is the previous 100 days data, to predict the current date value price. And I have plotted all the curves into the single graph. That is the 250 moving average and 100 days moving average, and also the original price. And then I have said about the percentage change. This is a small function which you can be used for some analysis. And I have converted like pre-processed this data into the range of 0 to 1 in order to make our model to train it faster. And then I took the x and y data from the scalar data I have done, and I have took the x and y data from the scalar data, that is the pre-processed data. This is the data, and I segregated the data into the training and the testing data sets. Then this is the model that is running now. See, it is not yet completed. It is still in epoch 1. It has to complete 2 epochs. It will take some time. Let's wait. So guys, it's completed now. Let's see the model summary now. Model dot summary. You can see the first layer is LSTM with 128 neurons, and then second layer is LSTM with 64 neurons, and then dense layer with 25 neurons, and dense layer with 1 neuron, that is the output layer. So you can see the parameters. So you can see the shapes and the number of layers it had using a summary function. So let's predict the stock data using this model, as our test data is already made previously. Predictions equal to model dot predict of x test. So let's run it. It's predicting the data. It's taking the test data and predicting the data. Let's see these predictions, how it look. Predictions. You can see all the values are in the range of 0 to 1, right? So I need to inverse transform them to get our original data. Let me do this. Scalar dot, I'm using the same object, and inverse transform of predictions. I'll be storing it in inverse predictions variable. Let me print it in the same cell. So if you see, it is ranged from 55 to 146, something like that. So we predicted our outputs. Now let's take the y-test data, that is the data where we have to compare it with. But the y-test data is also in the range of 0 to 1. We have to inverse transform them. So copy the same cell and paste it over here, but instead we have to give it y-test. Here also the y-test. Now you can compare all the values here. So here it is 55, and it is similar to that, like 53. Let's see the root mean square error, how it gets like the accuracy and the error. In order to do that, I can give this formula, np dot square root of np dot mean of, let me give this inverse mean of, I have to square this difference, inverse predictions minus inverse test, right? After that, I have to take the mean value and the square root value. That's it. So I'll be storing it in inverse RMSE, not inverse RMSE. I'll be storing it in RMSE variable, that is root mean square error. So let's see how it is. So let's see how much it is. So it is 2. So 2 is pretty much good value, I say. It has very less error. And let's see this data, the predicted data, in some graph format, right? That will be good. So in order to do that, I have want the data frame. So I'll be drawing the original data on this predictions data in the same graph, so we can able to visualize them all together. So now let's plot the graph with predicted values and original values. Before that, I need to map the dates, that is index with dates, to this data. Let me do it. Plotting data equal to, have to create a data frame like this, data frame of, you can give a dictionary here. Inside this dictionary I can give the original data, original data, that is, I can say the original test data, and this is nothing but the inverse y test, right? This is the original data, but while I'm transferring it to the data frame, I had to give it a one-dimensional array. But if you see here, it is a two-dimensional array, so I'll be reshaping it into one-dimensional array. Reshape of -1, so it will convert it into a one-dimensional array. And then the second value is the predictions. You know, it is inverse predictions, same as y test. I will reshape it, reshape -1. So, and then I have to add the indices, right? The date indices, remember? So the index is nothing but the Google data dot index. But wait, this test data is having only the 1433, right? So I can use that splitting length variable to get the exact index values. So splitting length place 100 values that I have removed from the training data until the lost values. So let's run it and see the data frame dot head to get the first 5 rows. So if you see here, the original test data and the predictions for 53 we got 55, 53, 55 and 54, 54. They are almost similar. Let's plot this graph. They are almost similar. Let's plot this graph. Plot graph of, I'll be giving the size first, 15,6, the data, that is plotting data I have already created, and the title. So this is the test data, right? So I'm giving it as test data. So I'm giving it as test data. Let's run it. Yeah, so if you see that a blue curve is the original test data and the predictions are the orange one. You see they both are almost similar. You can see the curves are pretty much accurate, because I said the root mean square error is 2. It is very less error, so it is predicting very correctly. Let's plot this graph with the whole data. So to do that, we need to combine our predictions to our original dataset. So I can do the same thing. Copy this, copy it here, paste it here. Instead of this plotting data, I need to concatenate the original data training set and this predicted results, right? So I can use pd dot concat. Inside this concat, I have to send this original data, that is inside the list I have to send it, that is the adjusted close price. I have to send the test data set, right? So I'll be taking the splitting list plus 100. So I'll be getting the adjusted close price test data plus the plotting data I have created here. And the axis is 0. You can say the whole data. Let's run it. So if you see, the adjusted close price is in blue color, and the original test data, that is also the original data we got it from the website, that is in orange color, and the predictions are in green color. They both are in exact same curve. So this blue data is the training data we took, and these are the test data we have predicted. So here the prediction ends, but wait, I have created a web app for this. Let me show the web app quickly. Before that, I have to save this model dot save latest stock price model dot keras. I'm saving it as latest stock price model dot keras. So it's created here. Let me open my VS Code to create a web app. So I have opened my VS Code here. I will be creating a file here, that is web stock price predictor .py. Import streamlit as st, and then we have to import our required libraries like pandas, right? Pandas as pd and numpy as np, and we have to import so in order to import this saved model, we have to import load model from keras. From keras dot models import load model, and we are drawing different graphs, right? So we have to import the matplotlib also. Matplotlib dot py plot, yes, plt. So until here, this point the inputs are over. So we have one more package, that is yfinance. We should not forget it because we are getting data from it, right? Yfinance as yf. So let's give the title for this web app, st dot title. Let's say stock price predictor app. So starting from the first step, I have to take the input, right? The first step is to take the input from the user. So which stock data he wants to pre-process and predict the data. So to take the input, have to give a text input, that is st dot text input of, I can say enter the stock ID like that, and I can give the default value here also, like default value is Google, that is Google. After that I have to define the duration, right? So to define the duration I have to import the datetime, like that, and define end and start, end date time dot now, and start date time like that, date time of n dot year minus 20 years, and n dot month comma n dot day. So let's download the data here. I can say same as this, I can say Google data again. It is just a variable, you can use anything. Download of the stock data and the start and the end duration, right? Before that I have to store this input in a stock variable, right? Here is the stock variable done, and then let me import this model here first. So to do that I can do model equal to load model of, you can do latest stock price model dot quires. You can give it like this. So let me take an header here, like the stock data dot subheader stock data, right? I can write the data here, st dot write of the Google data. So next step is to split the data into training and testing set, right? But we are not training here because we have already imported the trained model here, so we just need the test data set. Of course we have to split it. Let me take the splitting length. It is same int of length of Google data star 0.7, that is 70% data length. I can take x test from this variable. I can take x test pt dot data frame of Google data, but I want the close price values. I can even take the adjusted close price values, but let's take the close price values because they are almost same. I can say they will be same every time. This is the 30% data I have taken, and I want to draw different graphs on the web app. So let me define this plot graph function. I have defined it already in the Jupyter lab, so I am defining it here also. I am taking the figure size values and one more value, full data. So let me give it like this, fig equal to plt dot figure of fig size. You know that fig size is figure size, and we can plot like this the values, and plt dot plot of the full data. If I send the full data, I have to select the close variable first, and then let me choose the color. Let's take the full data color as blue and the values as orange. right? And if say, and let's return this figure, right, like that. Let me see this first how it is running. Streamlit, run. So let's see how it is running. So it is opening the web app here. It is not yet completed, but I'm showing how it will be like the UI. So this is the title I have given, and this is the input stock data I have given, the group, the default value, and the stock data. Until this point we have completed the web app. Let me complete it as fast as possible. Let me draw some graphs like ht dot subheader. Let me draw a graph for moving average of 250 days, as we did it in the Jupyter notebook. Let's take the original close price and moving average for 250 days, right? Let me store it in the Google data of moving average for 250 days and equal to Google data dot. You can either use dot or anything as you wish. Close rolling of 250 dot mean. So I'll be taking the average, moving average, and I will be plotting this on the web app using this Streamlit library. Plot graph of, I'll be taking the size as 15,6 again, and Google data of the same variable name, and also I'm sending the full Google data so I can able to see all the data, right? Let me copy and paste it for 2 more times because I want to view it for 100 days also and 200 days. Let me change it to 200, 200, 200. Here also it is 200, and one more time for 100 days, 100 days, and 100 days. And what if I want to print all the 250 moving average data and 100 days moving average data and the original price in the same graph? So I'll be copying this and pasting it here, and moving average for 250 days. It is the original close price and the moving average for 100 days and moving average for 250 days. But if you see, the graph only accepts 2 data sets here, but I have to give the third data set as 250 days, right? But I have to give the third data set as 250 days, right? So in order to get that, I will be creating another data set here. That is the optional parameter extra data equal to 0 by default, and extra data set equal to none. Let me give it like this. And if extra data is not 0, I'll be plotting that extra data set, the plot of extra data set. So cool, right? So by default it is 0. Even I can give it here 0, 0, 0. Even though if you not give 0, it will be printing it. So I can give it as 1 here. You can give it as 1 here, and the 250 rows data. Let me copy this and paste it here for extra dataset. So this will be plotting them. So next what I have to do is I will be taking the graph for original price and the predicted price. But wait, you didn't read the data, right? So that's where that's what my next step is. So let me pre-process my test data first. So in order to do that, I have to import the preprocessor, that is min-max scaler. So in order to pre-process that, I have to import the min-max scaler from sklearn. So from sklearn. So in order to do that, I have to import the min-max scaler from sklearn. So from sklearn dot preprocessing import min-max scaler, like that. And scaler equal to create an object scaler feature range from 0 to 1, and let's take the scaled data. This is the test data SN dot fit transform the test data that we have taken already, right? Let's take the close price itself. Let's divide it into a X data and Y data so we can compare it after predicting to calculate the accuracy, right? So Y data for I in range of, and taking the space as 100, so I'll be taking the previous 100 days, so I'll be taking the previous 100 days data to predict the current data. So I will be taking previous 100 days data to predict this price, comma length of scale data. So I'll be adding the data here, dot append of, same we did it in the Jupyter notebook, scale data, first 100 rows until I, so Y data dot append of scale data of I. So we need to convert it into a number array in order to give the value to the predicting function, right? So to do that I have to import numpy. It is already imported, right? Okay, so let's do it. Data equal to np dot array of x data, comma np dot array of y data, and then let's predict it. Predictions equal to model dot predict of x data. We have to inverse transform this data, right? So let's do this. Inverse predictions equal to scalar dot inverse transform of predictions and inverse of y text, right? Let's do it. Inverse transform of y text. Let me create a graph for that. We don't have text, so we'll be giving data y data, right? Okay, that's good. Let's take the plotting data here. I'll quickly copy paste from here. Let's copy this, paste it over here. So this is the plotting data. Everything is fine, right? So instead of plotting data dot head, so I can give it as st dot write off dot head. Instead of head I can give all data, so st dot subheader saying that it is the predicted values versus original values. So original values versus predicted values, right? And then at last a simple graph to show the original close prices and the predicted close prices in a graph format. So let's do that. Subheader original close price versus predicted close price, like that. Let's draw this figure equal to plt dot figure size. So I want to give the legend to this, so I'm writing it outside the function instead of calling that predefined function we did. I'll be copying it from here. The same data I will be plotting. Copy this, instead of adjusted I can give it as Google data dot close price, right? Good. And then I will be giving the legend. So the first one is data that is not being used because we are not using it for even training purpose also. And the second data is the original text data. The third data is the predicted text data. Let's plot this graph. Py plot figure Let's save it and see how our web app looks. I hope it is still running. Let's go to the web app. Refresh it. By default it is taking the Google data. It is printing the stock data here, you see, and this is the original close price versus the moving average for 250 days, and this is the graph for original close price and moving average for 200 days. This is for 100 days, right? But wait, they are almost same, because I should change this. I missed it. Let me change it quickly. You have to change it here. 200, 100. I don't need to give it here. I don't need to give it there. So let's save it. I think this might work. Good. Let's go to the web app, refresh it. So it's taking the default Google data. It's printing the stock data here, the open, high, low prices and closing prices, adjusted closing prices and volume. This is the graph between the original close price and the moving average for 250 days. And this is the graph between the close price and the moving average for 200 days. They both are almost same. And for 100 days, you see it is similar to the close, very close to the original price. And at last I have given the graph for close price 100 days and 250. You can see the close one is a curve for 100 days, moving average for 100 days, and this is for 250 days. If I go down, this is the original values and printed values for that close price. So they are almost similar, like with I said, right, like 2% error rate. They will be printing all these values. It will be printing all these values with a 2% error rate, but it has more accuracy, if I say. And at last, this is the graph for whole data. The blue line, it is data not used, and the orange line, the original test data that is being used to test the model, and the printed test data is in green color. You can see there. You can make it big, right? So this is our web app. Let's try for different data instead of Google. I can try Microsoft. For Microsoft, you can search it here. You can open this website and search for Microsoft. For Microsoft, it is a MSFT. You see MSFT. So if I, instead of Google, I can do MSFT. Enter. It is running. So see, it given the stock data for Microsoft here, and the opening close price for, and the original close price, a graph versus the 250 moving average day values. It has given the graph, and for 200 days moving average value, it is given the graph, and for 100 days, it is given the graph. If you see here also, for 100 days moving average, it is very close, like this. And if you see the printed values also, it will be 2% error rate. As we are not training this data separately, we have trained the Google data already with the 20 years data, and this is the test data we are taking from this Microsoft data, and we just printing it, right? We just imported our model. There and printed it here. This is the printed data and original data along with the date, and this is the last graph we have done to see the close price values and the printed close price values. And the blue color one, previously, as I said, it is the data that is not being used. Previously we have used it for training in the Jupyter notebook, but here we are importing the model, so we are not using it. You can use it for some other cases, like if you see the HDFC bank, it is a HDB. Let's try it. HDB, enter. So it is a stock data and the original close price and moving average for 250 days, and original close price versus the moving average for 200 days and 100 days, and it is a combined 200 and 250 moving average. And this is the printed values, and this is the lost graph I'm showing you every time for the test data set and the printed values. And this is the lost graph for the printed values, right? You can even search for a Bitcoin also here. Let's see, Bitcoin. It is BTC-USD, right? Let's search for it. BTC USD. If I send enter, it will be giving the train the data with this. If I give enter, it is showing all the data set here. And if I go up, this is the original close price for that Bitcoin data versus the moving average for 250 days. And this graph is for close price data versus the moving average for 200 days. And the moving average data for 100 days versus the close price data, it is very close than any other curve. See, it is very close, the 100 days value, and this is the combined graph for 100 days moving average and 250 days moving average. At last, here is the original values versus predicted values for that close price. So they are almost similar, you can say. And this is the last graph for the close price values and the predicted close price values. So in my next video, I'll be doing Bitcoin price prediction tutorial. Please subscribe if you understand and the content is very useful. Thank you.